if you've got a closed vessel that's locked up, and if you put caustic, particularly under heat, that carbon dioxide gas will turn into a solid. So all of a sudden, something that takes up a lot of volume now takes up very little volume, and you're going to create negative pressure, and you will implode your tank. G'day Brewers, welcome to Quality Focused Pro Brewers podcast. My name is Hendo and it's great to see you here today. And today I'm joined by a very special guest, a very good friend of mine, Kyle Smith from Gorman Smith. He is based in Toronto and I was very fortunate to head to Toronto in January of this year where it was very, very cold. How's it right now in Toronto?
Well, we're at
Kyle?
the start of October and it's about 20, 22 degrees Celsius, or that's for the Americans, it's that's
nice.
like 80, 85. So you're like not too warm, not too hot, but not cold yet. No snow, obviously.
If you can help me translate metric into freedom units, when I came over to see you in January of this year, it's the summer in Australia. And so I got on the plane in Brisbane, Australia, and it was 36 degrees Celsius. So typical middle of summer, very, very hot. I think that's cracking 90s, I think, in Fahrenheit.
Yeah, you're almost at 100.
36 degrees. Almost at 100 degrees. Got off the plane in Toronto and it was minus 15
and
Celsius.
That's where you're...
What's that?
That's like 20, 25 degrees Fahrenheit.
Oh, it's got to be less than that. It was crazy, just like, and because it was the middle of summer, but before I could get on the plane, I thought I'll go buy some winter clothes, but in the middle of summer, there's nowhere to buy winter clothes. So thank you for the gloves and thank you for the snood as well.
Yeah, we would call that a toque. A toque.
A toque. Yes, that's right. Yes, a toque. So it was so good. So very grateful for that. And we had a really good time in January. It was really good. So, mate, I thought today we would have a chat about Brewery CIP. And the reason why I reached out to you for this chat was you wrote a really, really good blog post on your website about I think it was called A Quick Guide about Brewery CIP. What was your motivation for writing that blog post?
So it was not too long ago that I had a company that I've worked with for a while, and they're not actually a brewery. They work in like water and carbonated beverages and stuff like that. And I was doing a quick audit of what they were doing, and the guy who, he's not a production guy, he came from food and beverage and restaurants and bars and stuff like that. So he knows how to serve the product to his guests, but he's still learning the manufacturing thing. And he was constantly confusing cleaning and sanitizing. So he was like, oh yeah, I sanitize. I'm like, no. Like, what's your cleaning procedure? I was like, oh, don't worry, I sanitize them. 2 steps back, it's like sanitization is important, but do you clean? And yes, once you're done cleaning, do you sanitize? And they're separate steps. And if you work in food and beverage in a bar or restaurant, you probably don't always think about those steps because you put it into the dishwasher, you press go, it does all 3 steps for you.
Yep.
There's no no thought about it, and you're like, yep, this is clean and for the guests. But when you're in a brewery, you have to do each step by yourself. There's no, unless you have one of those fancy diverter CIP systems at a really large brewery, you're doing each step yourself. And so I wrote the blog post for him so he could start to break it apart and think about, wait a second, there's cleaning and then there's sanitization, and the sanitization definitely helps, but it's not replacing for cleaning, and cleaning is not replacing for sanitization. You got to do both.
So just to take a step back here and about your particular background as well, is that, so you were talking to a guy who was not a brewer, not talking about a brewery, but you're a brewer yourself though.
I left engineering school. I finished up a degree, and then my first job was at a regional sized brewery here in Ontario at Cameron's. So I was the brewer and then the head brewer there over about 4 years. And then I went from that into equipment. And then I've had to design these systems and then show people how to use them in the field, because there's a lot of small things you don't think about. It's really easy to be like, oh, we're going to turn on the pump. Well, that pump has been sized, and the spray ball inside the tank has been selected for a certain use. So there's certain steps along the way that you can make it easier for yourself or more challenging for yourself.
Yeah, gotcha. And so and you do a little bit of consulting and advisory work to breweries and that sort of thing as part of what you do. When it comes to CIP in the brewery, you mentioned the separation of the different steps of CIP, of cleaning and sanitizing and that sort of thing. But when you go into a new brewery, what are the sort of, say, the top 3 challenges around CIP that you commonly see?
I think part of it is like people are still trying to, like, everyone gets challenged by some of the chemicals and what they're specifically used for. So there's certain chemicals that are for specific tasks, and certain things will come away easier by if you use the right chemistry, and then some things are going to be a little bit trickier to remove or clean. There's also clean, and then there's beer clean. And if we're not careful, we mix things up or we don't do things right. We don't use a proper sanitizer that is non-rinse, or we have to rinse it through. We could end up almost contaminating our beer, and like the smallest problem would be our head doesn't look very great in the glass. But the biggest problems can be, oh, we forgot to dump the caustic and now the pH is off, and there's all sorts of nightmares that can occur if you're not taking all those steps seriously. And the other challenge is it only takes a couple of cells to ruin a batch of beer. So I remember, yeah,
as
like
in contamination,
if you have
contamination
some
risk, yeah.
wild things or something like that somewhere in that specific fermenter, it's not like, beer is pretty resilient once it's made, but if it's in that initial wort phase, lots of things love to grow in there. I did an internship at La Molne Yeast when I was in university at their research facilities in Montreal here in Canada. And I remember like making a bunch of plates on Friday, and then I came in Monday morning and there was colonies in the agar. And my boss was like, how'd this happen? I'm like, I don't know. Like there's this really potent antibiotic that we were using because we were only doing yeast trials. So I'm like, now, like I have my notebook. I wrote down that I used the antibiotics because we were doing yeast. And he's just like, grab a sample of the antibiotics, put it on the microscope, and there was yeast thriving in this antibiotics. So it only takes a couple of cells to.
That's not a very good antibiotic,
man. Antibiotics work against bacteria. They don't work against fungi. So the fungi were perfectly happy in the antibiotics, but they obviously kill any bacteria.
Yeah, right. And what's the difference between clean versus beer clean?
Well, we want to make sure that there's obviously no soils, no dirts, no protein left over. But then we also want to make sure that we're rinsing thoroughly and that we're getting rid of all of our compounds, because a little bit of oils or a little bit of like hop residue from a previous batch, it can just degrade the protein structure of our next one. We also want to make sure that there's no flavor carryover from some of our brands. Like sometimes it's easy if you have a black IPA and then followed by a Pilsner and you leave a little bit left over. Well, that black IPA is going to make the Pilsner much darker, but it can get more complicated than that. Or if we have like a Saison with some yeasts that have STA1 genes, they can ferment out the beer drier than we want. So we want to make sure that we're treating everything and that we're getting it rinse free. Like if you go to a pub and you can almost see it in the beer glasses when they're not cleaning properly, the bubbles will stick to the glass and you're like, no, you can't see it with the naked eye, but there's something on that glass that isn't supposed to be there.
So you're saying that you can see when a beer is brewed and fermented on equipment that's not,
especially glassware. Like if you have a beer bottle that's not quite clean, the carbonation will stick to the contaminants.
To the side, yes, yeah, because I've heard the term beer clean before, but in the context of Cicerones and stuff like that, where they talk about glassware and all that sort of thing. But the same really applies for your brewing equipment.
Yeah, and instead of funky looking bubbles, we might get cell counts that we don't want.
Yes, which you definitely don't want. So when I talk to a lot of brewers, particularly on occasion that that they're home brewers that have gone pro, built their own brewery and that sort of thing. For many of them, it's the first time using commercial grade cleaning chemicals and that sort of thing, and they have this sort of false assumption that CIP in the brewery is caustic and PAA, paracetic acid, and that sort of thing. What are the different types of cleaning slash sanitizing that's done in the brewery, and what are the different chemicals that are associated with it?
First step, what we're going to do, we're going to do a hot rinse or use some water around the brewery. We don't care if it's too clean. We're going to try and get away as much of the protein and the hops as possible. We're going to flush the system, because when we flush the system, then our soaps are going to work better. So then we're going to do a caustic, and that's going to be an alkali detergent of some sort. So that can be sodium hydroxide, and that's going to help break down any, like the Krausen ring that's stuck to the fermenter. That's going to break down the proteins. Once we're getting that, we're getting most of the way there in terms of cleanliness. Like that is 80 to 90% at least of the work when we're doing that caustic wash. Then there's something called beer stone, which is calcium oxalate. And that's kind of a funny, like semi-organic salt that builds up on the inside of fermenters over time. And we want to remove this every once in a while, because if it builds up heavy enough, we can get microbes living in there that we don't want, and that can get protected by the caustic wash.
Yes.
So we want to do an acid wash on our equipment. Not every time. We can do it every few months or something like that when we're trying to get rid of that beer stone. And then once we've done our rinsing, caustic is horribly sticky. We want to make sure we're rinsing. We're making sure we're getting a nice neutral rinse water. Then we're going to sanitizer. And that is pretty much to make sure that everything, like we might have caustic washed a couple of days before and it's clean, but then we're like, we're going to put beer in it. Let's make sure that there's no little microbes or anything in that, or there's nothing in the rinse water. And we're going to add a sanitizer, and that's normally paracetic acid. You can use chlorine dioxide. That's a little less common because you got to almost make it yourself. And then iodophores are common too, but they leave a stain. The iodine will leave a residue, so you want to make sure you're rinsing that away too.
Beer stone's an interesting one because, like, effectively it's a mineral deposit, and you see it more on hot side, on brew houses, in kettles and mash tuns. It's especially steam kettles with steam jackets, or direct fired brew houses where the heat's coming, kettles where the energy source is coming from underneath, where things get especially hot. You get lots of beer stone.
Basically, that's because it's a reaction with some of the calcium in your wort or your beer with some of the hop compounds and some of the other things that are in there, and then it makes sense where it's heated, because it's basically just growing. It's like a mineral that's growing over time.
Yeah, and when you got it, because like you'll run a caustic and it won't physically look clean. And you're like, well, what the hell's going on here?
Type residue.
Yeah, exactly. You mentioned using acids to get rid of beer stone, like nitric acid or phosphoric acid and that sort of thing. I have used with some success as well, putting hydrogen peroxide into the caustic solution.
I've heard of it. I haven't done too much. Like we have the caustic, and then we can boost it. So you can use things like, sometimes you can use chlorine, but you got to be careful with adding chlorine as a booster to caustic. You don't want to let your stainless steel soak with a chlorine-based detergent over a long period of time, because it will start to pit. The chlorine will start to eat away at the stainless steel. Yes. I've heard of hydrogen peroxide using as a booster, because it basically adding oxygen to the caustic, and you're adding a lot of.
Correct. Yeah, it oxidizes the
and it breaks it apart. There's also some chelatants and stuff like that, and what they do is they make the beer store more soluble by breaking it apart, so you can rinse it away easier. So there's like EDTA and a couple of those other ones. Those are also heavy-duty chemicals. So the cleaning companies, they'll add a couple of those small things. Like when you buy your drum of caustic or your bucket of caustic from a chemical company, it's not always going to be just the sodium hydroxide. There's going to be a couple of those things in there. They won't share necessarily what's in it, because that's kind of their secret toolkit for making a good detergent.
Yes,
but they'll be adding some boosters to that to either make the caustic more effective or rinse away easier, or make it easier, make the compounds more soluble when you rinse it away. So there might be that in your cleaning chemicals already, but it's always best to ask the cleaning
Yeah.
chemicals.
Yeah, the I've used like over my brewing career, I've like here in Australia, we've got Sapura and Ecolab
Yep.
are the two main sort of suppliers, and there are others and that sort of thing, and there are probably others in your area where your brewery is and that sort of thing. But it was Sapura kind of called the caustic, and the mistake you shouldn't make is don't go and buy pearl caustic and expect that to work, because which is basically straight
Right.
sodium hydroxide. And you can buy it from the supermarket if you really want to. You can buy pearl caustic because it's the caustic soda you can use to make soap and all that sort of thing. But the issue there is that if you just use straight sodium hydroxide and water, that you need the wetting agents in what's superior. They call it a built caustic, because the surface tension of just sodium hydroxide and water is so high that the liquid doesn't reach the bottom of all of the pits in the stainless steel. And so you're not getting that efficacy, and you're potentially leaving soils behind in the bottom of these pits. And that's why you use built caustic that have things like EDTA and all that sort of stuff
Liquid
in it.
detergents mix with your cleaning solutions much more effectively. We've probably all noticed it at home where you have your laundry detergent. 10, 20 years ago, it was the powder in the box, and it's all gone to the liquid in the jug. Because if you read the powdered detergents, they're like, oh, you got to add this first. You got to add all of your water. You got to let it mix, and then you can add the clothes. I don't think people were doing that. So they're just complaining like, oh, your soap doesn't work. So we've all gone to a liquid format in our laundry machines. And because it mixes better, like it's a liquid and a liquid versus a liquid and a solid.
Yeah, agreed. I just won't mention that I shop at Aldi and I still buy powdered detergent for the laundry, but hey, here we are. So, what about for new professional brewers who are dealing with commercial grade CIP chemicals for the first time? In the homebrew space, you often use things like sodium percarbonate as your cleaner, and then you might use a phosphoric acid sanitizer and that sort of thing. Why are they generally not used in the commercial setting?
So sodium percarbonate is also it's the active ingredient in OxyClean, like the Billy Mays, and I'm here to talk to you about OxyClean, the wonderful yeah,
Like the
from like
infomercials
the
and that
late
sort of thing.
90s, early
Yeah, yeah.
2000s. And I think part of it is they're perfect. They're probably safe. They're much safer to handle, so you don't need you shouldn't be touching your eyes with it, but if it splashes, okay, you might ruin your shirt or something, but it's not going to be dangerous. And I think that's a big
Yes.
part of the commercial grade cleaning detergents and the home grade. I
Yes.
think PBW was developed, I want to say for a Molson Coors facility or something like that, eons ago. And they have some other things like sodium metasilicate and sodium bicarbonate, which is baking soda. So it's got their own blend
Baking
of
soda,
those
yeah.
three, and the three of them work together. If you've ever tried to use something like OxyClean to clean out your brewing equipment, it's going to leave a film. And I couldn't tell you what that is, but I think it's part of it is just handling. Like you can dose a certain amount of liquid caustic, but you're wearing your safety goggles, you're wearing gloves. At home, these powders, it's like, okay, you put a little pitcher into the soap container and you put it in. So it's much safer to handle in a home setting.
Yes.
With some of the acids, they're like it's really hard to get like nitric acid or phosphoric acid in big quantities, like at a grocery store or pharmacy or something like that. And I think that we use it because they're just super effective. Like it takes so much less time to use some of these things in comparison to like citric acid or TSP. They're just really good at what they do, and that's why professionals use them. But they have some safety considerations that we need to be aware of, so we're not risking or get hurting ourselves. The other thing that's going to be different from commercial grade and home grade, specifically in sanitizers, like everyone loves using products like Star San for the home brewery, and their slogan is "Don't fear the foam." Well, you can't use that with a CIP pump, because if you put any detergents that have a foaming agent in them through a CIP pump, you're not going to clean your tank, because your pump is going to spin a whole bunch on the inside and then it's going to create bubbles.
Cavitate.
So it's going to cavitate. We're
Yep.
going to get bubbles
Yep.
on the inside of the tank. It's not going to clean properly. The pump is going to kick out really quickly. So we don't want to use something that has a foaming agent in it when we're using a pump. So that's why.
And the other thing as well with foaming, if that's with Star Sand being a phosphoric sanitizer and it foams up a lot, but if you're using a cleaner, right, and it happens to foam, well, what can happen is the soil can sit on top of the foam in the tank, and you'll leave the soil in the tank.
Because as that foam out of the tank goes down, it's going to leave it behind on your cone.
Yeah, exactly. And that's the last thing you want. You want that soil broken down and out of the tank, basically.
Foaming detergents are great on the outside of the equipment when you have a foam gun and you're just foaming the whole brewery, because you want the foam to stick to the tanks for as long as possible. That's why they're great. But if you're using that pump, you don't want the foaming agent, because your pump's going to stop working pretty quickly.
Yeah, absolutely. So when we talk about CIP and just looking at your blog post there, and I'll leave a link to it in the show notes if you want to take a look at it. There's a lot of variables that influence the efficacy of CIP in the brewery, and I think you said it was
center circle.
Is that right? Center circle. What's a center circle? I was like, is it a person?
I was hoping it was a reference to Dante's Inferno and like the fifth circle of hell. the brewers that don't clean their equipment are destined to
that's very metal.
No, but there's this chemist in the 60s, and his name was like Dr. Herbert Sinner, and he just observed over time, if he changed the time, the temperature, the chemistry, or the mechanical action of his cleaning procedure, he'd get different results. So it's you think about, like, it's hard to picture in a big fermenter that you can't see in, but if you have a really, like, if you made lasagna and your pan is just coated in tomato sauce, it's like, okay, I'm going to need to soak this for a while, but soaking by itself isn't going to fix the problem. I'm going to have to use some hot water, and I'm going to have to use plenty of soap, and then I'm going to have to break out the elbow grease. We can think of that too when we're cleaning the inside of a fermenter. So we need to make sure our water is a strong enough temperature. We need to wash it for a certain amount of time.
Yep.
The caustic solution has to be a certain percentage. And then we're using a pump, and that pump has to be big enough for the fermenter we're using. And then the spray bowl has to be designed for that tank. Like those little shower head spray balls, they're only good for about 2.5, 3 meters in diameter. If you have a much bigger fermenter, you need a fancier spray ball. So, and
I've seen that. I've seen it. I saw in a brewery, some very good friends of mine commissioned many years ago, and it was the first time that this particular fabricator had made such big fermentation vessels, and they put this tiny little, like, I swear it was 1 inch static spray ball in these tanks. And so whilst we could pump through them effectively and that sort of thing, because it wasn't a rotating spray ball, what happened was the sprays went out so far, because the large diameter was like a 4 meter diameter of the tank, 3.5, 4 meters. And by the time the spray got to the edge of the tanks, it was leaving gaps between the little jets. And the tanks weren't being cleaned, and we were having all these micro counts and all that sort of stuff. And it was like, looked at it and it was just like, hang on a second here. I think we need to put something that rotates in,
and then you can go if on the super deep end. They're super expensive, but there's like super I think they call them jetting machines when they get that complicated. Yeah, so they're
cool. So
what they do is they use a super concentrated stream of liquid, and they spin in a way to do like a pattern. Yeah, around your tank, so that you're always getting part of it.
They're really expensive, but they're really good. Like a Rotocek.
Oh, there's some
people make. Well, the ones that I know were for that in a brewery that I worked in were for big 400 hectoliter tanks, and they were $8,000 each. And basically, what it did was it painted an up and down spray, but it wouldn't get everything on one lap around the tank. So it would have to do a certain number of laps. It's like when you get like a funnel with some sand and on a piece of string, and you just let it swing and it draws. Well, eventually, if you let it go long enough, and if there's perpetual motion, it's going to fill in sand everywhere and that sort of thing. And that's how these
We had
things
these
work and that
little
sort of thing.
gear
So
coloring things when I was a kid where you put your pen in and the gear would turn around and would make a pattern.
yes,
And the first time it was
yeah,
like, well, that's not very interesting. And you kept doing it and it'd be more and more interesting. It's like that.
that's right. Yeah. So the variables
Yep.
being time, the amount of time that you CIP something, temperature. So with it, and this is chemical dependent because some chemicals hotter is not better. I know, for instance, that I've been advised that, for instance, if you put in peroxide into your caustic to deal with beer stone, that the tank shouldn't be too, that the cleaning solution shouldn't be too hot because it will damage the stainless steel. You've got the chemistry, so in particular the concentration of the chemical, and then the fourth thing is the mechanical action of how the scrubbing action of effectively of what you're doing when you're undertaking the CIP.
Yeah, and if you
about right.
And that they're all in the balance too. So if you're like, oh, I added hydroxide, so I need to be a little bit colder, then you're like, okay, I might have to add a couple of minutes to my run in order to get the same level of cleaning. Or you're like, oh, I'm spending so much money on chemicals. I'm gonna go from 2% to 1%. Well, then you're probably gonna have to run the tank cycle much longer then. So it's all kind of a balance.
Yeah, or hotter or something.
So they're all.
Yep. So it's those. So basically, if you think about the analogy, it's 4 dials that you are in control of in the brewery in order to get
and if
clean,
you have it
ultimately.
the right temperature at the right concentration with plenty of mechanical action, then your CIP cycles are going to be much shorter. But if you're not factoring in everything in an even amount of, then it's going to take much more time, or you're going to have to run it hotter, or your chemical bill is going to be up through the roof. It's just going to depend.
And if you've got a weak pump and you're not getting that mechanical action either as well, that's going to take longer. Okay. So once I've cleaned a tank and I want to know if the tank is beer clean, I know it's clean.
You can use your noggin, as you would say in Australia.
I'll just look at it.
You can use your head. You can use your noggin, literally.
Yeah.
And you should do a visual inspection. You should always be looking inside your tanks after a caustic cycle and just being like, grab the flashlight, they call them inspection mirrors. They're these little mirrors on like a collapsible wand. They're like $10, $15. Mechanics love them. Grab some of those. Just physically look in the tank and be like, did I do my job? Or can I see a Krausen ring? That's the easiest first step. If you still have a Krausen ring on, then you're like, oh, I need to do the caustic cycle again. That's a no-brainer.
Yes.
And you can also see where their spots are or where your beer stone isn't quite forming. It's a lot of the stuff is pretty easy to visually inspect. And then you want to make sure that your concentrations are on the right level. So your caustic is in an approximate pH level that it should be. If you're using sanitizers, I think it's about 200, 250 parts per million that you want for PAA. They have test strips and drop kits. When you're done sanitizing, you want to make sure your PAA is at the right concentration, because too low, it won't sanitize. And then too high, it will leave some of it behind. And PAA, when it breaks down, breaks back into a peroxide and acetic acid. That's where it's called paracetic acid. Well, peroxide will oxidize your beer. So if you have way too much in it, then you're going to leave this oxygen in your beer, and you're like, oh, I did my purges and I did everything right. And then you add it in, and your PAA just put on 30, 50 parts per billion of oxygen.
Exactly. I've seen that. And that's particularly important using paracetic acid post-fermentation on things like packaging equipment and transfer lines and that sort of thing. And bright beer tanks, exactly. You've got to be so careful, because more chemical doesn't mean more effective sanitizing. Because if you use too much PAA and you leave that residual hydrogen peroxide in the tank, it's going to oxidize your beer. Right? And it's instantaneous too, and can be worse than exposing the beer itself to air and to oxygen and that sort of thing. So and to your point about validating the strength of the chemicals that you're using, all good chemical suppliers will either have for sale, but if they're nice, they'll give it to you for free, dropper kits or test strips, right? So my main chemical supplier, they supply you with a titration kit, because pH doesn't necessarily tell you the strength of caustic, but doing a titration is more accurate. And so you'll get some sulfuric acid and you'll get some phenolphthalein indicator, and you'll do a little titration of your caustic, and getting a certain percentage of free caustic is the most important thing, because the caustic liquid that you might buy from your supplier might only contain anywhere from 25 to 50, 60% of sodium hydroxide. And it's the sodium hydroxide concentration that we want to measure. So don't think for a second that this number of milliliters or liters of caustic into this much water to make a solution is the right amount, because it varies from chemical supplier to chemical supplier. So titration for caustic is super important. And there's test strips for PAA, and there are also titration kits as well for PAA to make sure that your sanitizer solution is, on point and that sort of thing. But coming back to validating and verifying if a piece of equipment is clean, and to your point as well, where you said, well, just one cell is enough to ruin beer. Well, what if I can't see that one cell?
You can plate it, but that can take 3 to 5 days to the plates screw up, and we don't always have that time in a brewery. We're like, did we do a good job at the sanitizing the bright tank? Looks good. We need to put the beer in. If you have a little bit of a spending budget, there's these things called ATP meters, and what ATP is, it's like the energy source in a lot of cells, and what it can do is you take a swab, and there's a bioluminescent chemical in these swabs, and you put it in the meter, and it gives a reading. If there's no ATP there, then it doesn't light up and doesn't glow. So that means there's no cellular activity. So we've completely removed all these little cells across that sample size. It's really good on
ATP
it's really good underneath manways or on the bottom valve of your tank, because if it's going to be somewhere, it's going to be probably in one of those two places. They're a little bit pricey, so you probably, it's like, if you're a larger brewery, they're probably a no-brainer, but if you're a small brew pub, you're like, sorry, I can't afford that. That's understandable. But I know some of the contract canners here, they use it. They swab the port. They're like, oh, it's that bright tank, and they take an ATP meter and they swab that butterfly valve. And if that valve's not clean, they say, we're not touching the beer because you're going to get our equipment all funky. So
yes, their ATP meters are a great insurance policy. It's really interesting. So ATP is like that, is life force in everything that's living. So you and I have ATP. That's our energy. It's in yeast. It's in bacteria. It's in plants, animals. Everything that's alive has ATP, right? And I'll leave a link to I actually did a YouTube video on ATP meters and stuff like that. And I'll leave a link to that in the show comments, in the show notes. The bioluminescence that happens with ATP, that little liquid where you snap the stick and you send it down to the bottom of the ATP stick, that's actually an enzyme, and it's called luciferase, and it's the same enzyme. Have you ever seen like glowworms and fireflies that glow in the dark? Same thing. It's basically that enzyme, and ATP is making that bioluminescence. It's fascinating stuff. But obviously with an ATP meter, the bioluminescence that happens, well, there's not, if you're checking that a tank is clean, there's obviously not a lot of ATP in, and we need to have really sensitive equipment. So the bioluminescence you won't be able to see with the naked eye, but the ATP meter can, because it's a very sensitive instrument.
You might have killed all the cells in there, but the ATP from those cells is still active, so you haven't done enough rinsing or enough sanitizing yet. That's why those will go off.
Yeah, absolutely. So, all right, tank passivation. Let's talk a little bit about that. All right, tell us, what is passivation, because my understanding of it is it's something that you do when a tank is new and that sort of thing, to get it ready for first use and all that sort of stuff. What's your thoughts on tank passivation? Is it something I should do on a regular basis? And how should it integrate into my brewery?
When we say passivation, there's it's a specific term, and it gets misused a lot. They're like, oh, I passivate every 3 months. So we actually have NASA to thank for a lot of this research, because if you send a metal to space that isn't passive, it will cold weld in space, because there's nothing in between those two metals, and the atoms aren't very smart. They just say, oh, that's another metal that I want, so they'll all join up.
I'll
So they
join
fuse
up.
right
Yep.
together in the vacuum of space. So NASA learned very quickly, in order to prevent this, all the metals they send up to orbit, they need a passive outside layer. When we talk about brewing equipment, it means we're making an oxide layer that is physically stable. So stainless steel, it's got some parts that are iron, it's got some parts that are nickel, there's some parts of chromium. That's the difference between mild steel and stainless steel, is the chromium, and there's a couple of other components in there too. When we passivate, we're using a very concentrated acid to chemically remove the outside iron atoms. So we are basically taking a chemical like X-Acto knife and just scraping the alloy. So when we do this, we're doing this when the equipment is brand new, or we've done a lot of repair work on it, or we're starting to see rouging. Like, stainless steel can rust, so if we see like red streaks on the inside of the tank, then we're like, okay, probably we should passivate this. And because we don't want that free iron in our beer, because iron will turn to a blood type flavor, or pennies. It's pretty gross.
Yes. And humans have a very, very low threshold
Yeah.
for iron in beer.
So when we get a new tank, so we ordered our new tanks and everything, and then you say, hey, to the manufacturer, do I need to passivate this? The the welder, like, they're going to cut the stainless steel, and they're going to be breaking any oxides when they're using their cutting tools and their welding tools, and they might be like spot treating the welds with an acid to remove the heat stains from those welds, or they're polishing it. But generally they're going to say, yeah, we didn't passivate this, so yeah, probably a good idea to. We want to use some sort of degreaser, like a very heavy duty degreaser. I would stay away from caustic from this one. Caustic's great at breaking down proteins, but we want to use like something that's going to break down oils specifically. So we want to use a heavy duty degreaser that's food safe. We want to remove any just oils from shipment or from the steel shop. We want to remove that all so that we have the metal finish, and that's what we're cleaning. And then we're going to use either nitric or citric acid at a very high concentration to chemically remove that iron. And then once those chemicals are removed and rinsed away, we now have a bunch of free chromium, and the chromium is going to oxidize slowly. So iron oxide, everyone knows rust. It's red, it's flaky.
Yes,
it breaks
yes,
apart.
yep.
Chromium oxide is stable though, so it's going to change in tint a little bit, but it's chemically stable, so it doesn't break apart and fall apart on us. So when people say, "Oh, I need to passivate again," I'm like, "Well, hold on a second. What do you mean? Do you mean you just got these tanks in, or you just had a welder in and they were trampling around the equipment and making cuts in the steel and doing a bunch of work, or do you mean I want to remove beer snow?" Because those are very different things. So yeah, I wouldn't
Yeah,
do it to a.
absolutely. Is it something that so you're saying it's something that you don't necessarily want to do regularly as a like a remedial
No,
clean for a tank, say every few months,
because when
three
you're
to 6 months or
passivating,
something
you're
like
using
that?
about 20% nitric acid. Your regular acid wash is going to be 1 or 2%. And the other thing is, you want it to, like, if
Yes.
you're passivating, it has to be nitric or citric acid. Phosphoric acid doesn't remove those iron ions for whatever reason. It just doesn't. So it has to be a super concentrated nitric or citric bath. That's really dangerous. So I was setting up a brewery a few years ago, and we had just gotten these tanks in from China, and the brewer, he's a smart guy, so he's like, "Oh, we need to passivate this." And I'm like, "Yeah, you're right. That's a good idea." And he's like, "Well, the boiler isn't set up yet. That doesn't get installed until next week." And he's like, "Well, I have this keg washer here, and it's got a heating element in it. Why don't we put the chemicals in that and heat that up and use that?" I'm like, that could work. Like, I don't see any problems with that. I didn't realize the heating element in that was copper. So
Oh
he
dear.
he he heats it up, because like they should be stainless steel elements in a lot of this equipment, but this manufacturer used copper. And copper is fine for caustic. It's not fine for acid solutions. So after about 5 minutes, the brewery's like, Kyle, something's weird's happening, and you look inside the little chemical reservoir under the chemical on the keg washer, and you saw little lightning strikes in it, and I'm like, shut it off, turn it off. When we drained the tank, the brand new copper element had completely dissolved into the acid bath. So the little lightning was literally the 120 or 230 volts. It was
arcing out.
It was basically short circuits inside the tank. We are so lucky no one got hurt. We are so lucky. And all we had to do was swap out that heating element at some point. But passivation is really tough on your equipment. It's really tough on brass. It's tough on copper. Any of your gaskets and your pump seals, it will, you almost want to do it and then change all the gaskets because it's that tough on the chemicals. If you have a new floor, you don't want your passivation liquid to touch your flooring because if you have the wrong epoxy, it will yellow it. It is that intense of a chemical concentration. And then you got to be,
Isn't that interesting? It's like brewers need to be metallurgists,
the mechanic,
as well.
the forklift driver, the plumber, the electrician, the butcher, the baker, the candlestick maker, yeah,
we're all those.
And then so you have this super concentrated acid, and then you're like, oh, I'm just going to dump it down the drain. Your concrete sewers are going to react with that. And your city engineer is going to be very upset if he finds out you dumped 20% nitric acid in the sewers. Very upset. So it's one of those things where it's like, oh, I'm going to passivate. Please don't. That's very dangerous. We don't need to. It's like, do it once. Do it if you need to repair the tank. If it's really starting to rust out because you've had the brewery equipment for forever, yeah, okay, but it's not something don't say it's like, oh, I need to remove beer stone next week and then say I'm going to passivate the tank. It's just dangerous. Yeah.
Different job. Yeah, and it's a different job. Yeah, exactly. I want to get your top 5 tips, your top 5 CIP tips. But before we jump into that, if you're a professional brewer and you're listening to this podcast, come and join the conversation over at the Facebook group. If you head to qualityfocusedprobrewers.com, there's a link to all the episodes, and there's also a link to the Facebook group. It's pro brewers only, home brewers. We make sure you answer some questions before you enter the group. There was a really good, I don't know if you saw that question this week, Kyle, about the guy in Melbourne who was asking the question about venting a tank before cleaning it and getting the CO2 out, because that's another thing as well with CIP is CO2 and sodium hydroxide. So we'll talk to that in a second, but yes, come and join the conversation. Head to qualityfocusedprobrewers.com. Come and join the Facebook group. We'd love to see you. Let's talk about CO2 and sodium hydroxide.
Yeah, so there's something called the carbonic cycle. So when we have minerals in the earth, it's a calcium carbonate, and then it slowly dissolves into calcium bicarbonate, and that goes into the water, and then sometimes it evaporates into carbon dioxide over years and years and years. And then sometimes the carbon dioxide dissolves into the water and creates carbonic acid and then dissolves carbonates. And it's a cycle. It's just like the rain cycle and all these other cycles in nature. Yeah. So when you introduce a heavy caustic to an environment that is full of carbon dioxide, the carbon dioxide is still going to want to turn into carbonic acid in that cleaning liquid. Well, you now have an acid in base. So you have the sodium hydroxide and the carbonic acid, and it's gonna be a sodium carbonate of some sort. So and then that's not very, yeah.
Well, it is sodium carbonate. That's exactly what happens. So you create carbonic acid, which is going to weaken your caustic, and the other thing that's going to happen is you're going to create sodium carbonate, and I think that's potash. Right. And what happens, so all of a sudden, if you've got a closed vessel that's locked up or bunged or whatever you call it over your way, and if you put caustic, particularly under heat, that carbon dioxide gas will turn into a solid, into a salt. So all of a sudden, something that takes up a lot of volume now takes up very little volume, and you're going to create a vacuum. You're going to create negative pressure, and you will implode your tank.
which is super scary. Which is super.
And I've got some really good
scary
photos
stuff.
in the old Hendo quiver. It's really, really scary. So yes, absolutely, vent a tank before you caustic it.
You
But
can
anyway,
collapse a tank just by using hot and cold water without it properly vented.
oh yeah,
We
absolutely. That's why you have pressure relief and vacuum
we
relief
build these
valves in
tanks to be
tanks.
super resistant to the beer inside pushing out, but we don't build them to do a good job at any internal forces
Negative
sucking in.
pressure.
So one thing you can get away with that
Indeed.
is your fermenters, you should be using caustic. Like there's all these hops and proteins and yeast. Let's use caustic. Vent the tank, open it up, let it sit for a few hours, because just because you open up the tank doesn't mean the CO2 is coming out. So we want to make sure it's nice and open and vented. You want to make sure your PRVs are clean every once in a while, because when they open, when they release, and there's beer inside, the beer gets in the PRV and it can make it stuck. So
seal,
every once in a while, like especially after you hear your PRV blow, be like, I need to take that off the next time that tank is out of use. So it's simple. You soak it in some caustic, you open it and close it a bunch of times. If you have a little toothbrush, you can use that, but you want to make sure that those PRVs are nice and clean and operating perfectly, because you don't want those to fail. And then to get around it, so years ago we were just sanitizing the bright tanks on a batch to batch basis, but then we started noticing cell counts. And the problem was we went from the nice clean filtered beers to we're starting to do the unfiltered IPAs at this point in the industry. And so we're putting products that have some yeast and other things in that, and we started noticing in plate samples. So what we started doing is we started using our acid blend, or nitric phosphoric acid blend, and I would run, because you can clean a bright tank with acid. If you're not putting a lot of yeast, you're not putting a lot of trub in there from the process, you can clean under pressure, so you're not bleeding out all of your expensive CO2 into the atmosphere. Like your fermenter, you're not purging it really. Like you might put some pressure on it to make sure it's sealed and holding pressure, but your bright tank, you are using lots of carbon dioxide to make sure all the oxygen is out. So if you're saying, oh, I don't want to bleed all that really expensive CO2 every time, I'm going to use an acid wash in between runs.
And you're going to clean the tank under pressure. Yeah, acid under pressure. AUP, CIP. That's one of the skills that you can learn at the Rockstar Brewer Academy, is how to do acid under pressure CIP. Good for your beer, good for your CO2 bill, and it's a time saver as well, doing acid under pressure CIP, because you don't have to break down the tank and vent it and then wait hours and hours and hours for the tank to purge.
You can turn it around in about 2 hours.
A little bit of effort's time saver. Yeah, exactly. So, mate, give us your top 5 tips for CIP in the brewery.
Okay, so the first one is, it's always going to be wear your PPE. Like I don't care what kind of brewer you are, just get your safety glasses, get your gloves. If you're really fancy about your PPE program, make sure you have like an overshirt or overalls or something that's make sure you're not wearing pants that are jeans and heavy canvas. Wear your proper clothing. And like I have to be like I cannot stress this enough, because it doesn't take much for you to get severely hurt when you're using super concentrated caustics. When I was brewing, I had a shit pump. Like the casters were all rusted. Like it wasn't quite great. It always cavitated because it was on an on-off starter and not a VFD. So it would constantly cavitate, and we've probably all had that thing where there's an air bubble at the top of that centrifugal pump. And of course, I did that. Well, I'm just going to loosen the tri-clamp a little bit to get the air out. Unfortunately, like the tri-clamp came loose. And the hose fell and I got sprayed. But I was wearing my goggles. I had some coveralls on. I took the coverall off. I went to the chemical shower. It looked like I had a bad basically looked like I had a bad sunburn. But I'm just thinking, it's like, if I wasn't wearing safety glasses and I got that much 60, 70 degrees Celsius chlorinated caustic right in my face, I would have been in the hospital at least. I might have lost my vision. It only takes once, and I know breweries are busy environments, but if you hurt yourself, that you're spending 2-3 weeks in the hospital, well, you're not making beer for 2 or 3 weeks.
Yes. And
It's
brewing
fine.
is fun, and being in
No.
hospital is not fun.
No, it's not fun.
Right. What else you got? What else? What's the
I'm
other
gonna-
tips?
I think
The
I think
PPE?
so we PPE, like safety glasses are cheap. They're like $2-3 a pair. When they get scratched, throw them out, get a new
Oh, yeah.
pair. Just wear your PPE. I don't care if you're Superman. Just wear your PPE. Install 3-compartment sink somewhere on your production floor. And the reason why I say that is because we've all worked in breweries where you're cleaning out of buckets. It sucks. It's not fun. If you hate doing the dishes, how often are you going to do the dishes? If you hate cleaning your parts out of a bucket, how often are you going to clean those parts? So it doesn't have, like, you can get super fancy clean out of place systems that like have these baths with pumps, and you cycle them and they clean everything yourself. They're ridiculously expensive though. They're custom equipment normally. We don't need something fancy, but if you were opening up a restaurant, the health department would be like, well, do you have a 3-compartment sink, or at least a double compartment sink, so you can use the soap in one compartment and then you rinse and then you sanitize in the last compartment? Just build yourself a proper sink so that you have a way to scrub
Yes.
all of your elbows, your T's, your valves, rinse it, sanitize, and then put it on a pegboard so it's nice and clean and dry for you to then use it the next time.
Yep.
It's also good for hand washing.
Absolutely.
Like you should be washing your hands constantly. We get dirty, we get greasy. Just wash your hands. If you're really fancy, you can put an eye wash station on some of these things. So you have a proper eye wash station, so that when you're doing something like I am and your hose falls and you get sprayed with chemicals, your eye wash station is in the middle of the cellar. So tip number three, make sure your pump cart and your spray ball are sized for the job you have. So just like those really big 4-meter or those 12-foot tanks and the little shower head, that's not good enough. You're going to need a certain spray ball for a certain size tank. If it's a mash mixer or a water ton, you might need 2 spray balls just so that you get both sides of the equipment. There's like static spray balls are great for simple vessels, but as you get more complicated, you might need a more complicated device. And then making sure the pump is properly sized for the vessel, because you can use a 2 horsepower, I think that's 1 kilowatt pump. Like every brewing equipment manufacturer will sell you a 2 horsepower pump, and they're like, oh, that can clean your cellar. That's only really good until about 20 to 30 hectoliters or so, depending on the dimensions of the tank. We care about the tank circumference when we're washing them. We don't care about how tall they are. If your pump is undersized, it's not going to hit those walls, and it's not going to hit it hard enough to break up that krausen ring and to remove those soils. So we want to make sure our pump is properly sized. VFDs have gone so cheap in comparison to on-off starters over the decades. Just spend the extra, $300-$400 on a VFD. If it's not getting quite clean enough, crank up the VFD. If it's going a little too hard, turn it down. On-off pumps, we really shouldn't be using them anymore. And then we want to when we're done our clean CIP cycle and we're done everything, we want to sanitize as close to the use as possible. So if we sanitize, we really should be using that tank either that day, no more than 24 hours, because we might have cleaned everything and we did a good job and we killed the 99.999% of everything. Well, if we let it sit over a weekend or over a week or however long, that one cell might have some friends now, and we're not doing our good job as little yeast shepherds anymore. So sanitize as close to when you're using as possible. Put some CO2 on your tanks. Make sure it's sealing. Make sure it's holding pressure. That's just good CIP cellarmanship. And then every once in a while, you want to take your tank apart. It's not a fun thing to do, and I'll admit it's not fun. Take it apart every so often. Look at the gaskets. Probably every 1 to 2 years, you want to replace all the gaskets on your fermenters, especially if you're doing funky beers, because the gaskets are where you're going to get contaminated. So they're great, but if you're not using them properly, it will hide. You want to make sure you're using the properly sized gaskets for those parts. A lot of brewers confuse 1 inch and 1.5 inch TC. They have the same outside diameter, but they have slightly different orifices on the inside. You want to be using the right gaskets in the right place, because otherwise, if there's a spot in that steel and you're like, oh, I just used the 1.5 inch gasket and they're all 1 inch fittings, well, there's going to be a little crevice in there where all the yeast and bacteria are going to hide.
Yeah.
So, and then
Absolutely.
You want to, tri-clamps and all those fittings should be finger tight, maybe a good quarter turn after that, because too much tighter than that, you're going to start to squeeze that gasket, and that gasket's not sitting in that fitting anymore.
Yes.
So,
yes,
I had a customer a few years ago. They're like, oh, they did something smart. They got those brass nut tri-clamps, because they're like, no, we're going to stick this on every port that's in between the valve and the tank. So you're never going to take off a tri-clamp unless you really want to. And I'm like, that's a smart idea. And then a couple days later, they're like, your gaskets are shit. They're falling apart. I'm like, what's going on? What are you doing? And they're using an impact wrench to tighten up all the fittings.
Oh.
So they have these nice, pretty bolted clip.
No, it's not a pit stop at the NASCAR
one, but the fitting just kept compressing the ferrule so much that the gasket split out the sides. So
yeah, of course.
Yeah, make sure.
That's insane. Mate, that's some bloody good tips there, mate. Especially the Formula One. Don't treat your tri-clamps like Formula One pit stop.
Yeah, like maybe a quarter turn afterwards.
It's amazing.
And like, if you're really not sealing at that point, you should probably take a step back and be like, okay, why isn't my piping sealing? Because it's only a little gap. The tri-clamp is only there to connect the fittings. It's not there to do all the heavy lifting.
Yeah, exactly. Mate, Kyle Smith from Gorman Smith, thank you so much for joining us today. If you want to come and join the conversation, thank you. QualityFocusProBrewers.com. Come and join the Facebook group and that sort of thing. Would love to see you. Thanks heaps for joining us today, and we'll catch you brewers soon. Cheers.
Yeah.